Okay, well, good morning. So this is a video on being able to multiply or divide radicals that have different indices. If you want to recall, when multiplying radicals that have the same index, we're going to be using the property, like for real numbers, the square root of a times the square root of b is the square root of a times b, right? The cubed root of a times the cubed root of b is the cubed root of ab. But what happens if they're different radicals, right? So if we have different indices, then we have to recall properties of exponents, right? So for example, if we want to take the square root of 2 times the cubed root of 2, we're not going to be able to multiply these together to get the cubed root of 4 or the sixth root of 4 or whatever, right? We have to think about rewriting in exponent form. And when we rewrite in exponent form, then we can apply properties of exponents to be able to help us resolve the multiplication. And recall that the square root of 2 is the same as 2 to the 1/2 exponent. And the cubed root of 2 is 2 to the 1/3 power. And now they have the same base. And so if we multiply things that have the same base, we're using the property of exponents that says x to the a multiplied by x to the b is equal to x to the a plus b. So if they have the same base, we multiply, we keep the bases the same, and then we add their exponents. And so this is going to resolve as 2, and then we add the exponents 1/2 plus 1/3. And now recall how to add fractions. We need to find the common denominator. That common denominator would be 6. So we have 2 to the 3/6 plus 2/6. And now they add together to give us 2 to the 5/6. And that's correct in exponent form. But now we want to rewrite that back in radical notation. And so in radical notation, remember that if we have x to the m divided by n, that's the same as the nth root of x to the m. And so 2 to the 5/6 is the same as the 6th root of 2 to the 5. And 2 to the 5 is 32. So this is the 6th root of 32. 6th root of 32 as a solution. So when we multiply those two radicals together, right, we had the square root of 2 multiplied by the cubed root of 2. This makes the 6th root of 32 as a solution. So if the radicals are different, convert them into exponent notation, and then recall properties of exponents to help you resolve the multiplication or the division. Let's look at another example here. Let's do a division problem here. So maybe we have, let's say, let's do the 4th root of 5. Now let's do the square root of 5 divided by the 4th root of 5. While rewriting in exponent notation, we would have 5 to the 1/2 divided by 5 to the 1/4. And now a property of exponents that we will be able to apply says that if I have x to the a divided by x to the b, this is equal x to the a minus b. So if they have the same base, we can subtract their exponents. And so we would end up with 5 to the 1/2 minus 1/4. And a common denominator puts that as a 4. So 5 to the 2/4 minus 1/4 is 1/4. So we have the square root of 5 divided by the 4th root of 5 is equal to the 4th root of 5. It is 5 to the 1/4 is the 4th root of 5. And so again, properties of exponents when they are different radicals. A more challenging problem would be what happens if we have not only different radicals, but different radicands. So maybe we would have something like this. The square root of 2 times, let's say let's do the cubed root of 2 times the square root of 3. So now these have different bases, so we're not going to be able to add their exponents like we did in the previous problem, unless we can figure out a way to either make them the same base or use another property of exponents. But let's start by converting them into exponent form. This is 2 to the 1/3 multiplied by 3 to the 1/2. And now ideally, the property we want to use this property that says that if you have x times y all raised to some power, this is x to that power times y to the same power. And so we're going to use this property in that direction. So we want to ask ourselves, can we make those powers the same, right? And not only the same, can we make them have maybe a common denominator, right? And if we think about that, right, 2 to the 1/3 is the same as 2 to the 2/6. And 3 to the 1/2 is the same as 3 to the 3/6. Right? So 2 to the 1/3 is 2 to the 2/6, and 3 to the 1/2 is 3 to the 3/6. But now look at this property here. Remember that if we had x to the m divided by n, that's the same as the nth root of x all raised to the nth power, or the nth root of x to the n. So this is the version we want to look at. Right? We want to see this as 2 squared to the 1/6 power, and then 3 cubed to the 1/6 power as well. And 2 squared is the same as 4 to the 1/6, and 3 cubed is the same as 27, and then we have the 1/6 power. And now, since both of those have the same exponent, we can multiply the bases together. 4 times 27, and this is all raised to the 1/6 power. And what is 4 times 27? 4 times 27 is 104. Let's see. 4 times 27 is 108. So we have 108 to the 1/6, which is the same as the 6th root of 108. And so that tells us that the cubed root of 2 times the square root of 3 is the same as the 6th root of 108. And that would be a challenging problem when they have different radicals and different bases. Right. Anyway, I hope that helps. Have a good day.